Dear learners, welcome to week 5 lecture 2. Till now I have covered the basic definition of differential geometry, specifically required for developing the cell equations. Then I have developed a partial differential set of governing equations based on first order shear deformation theory. And in the last 4th week, I have derived the special cases that can we get the governing equation for cylindrical shell, spherical shell, plate, circular plate and so on. And this week in the first lecture, I have given the basic guidelines that how do we can derive the governing equation for a infinite shell panel and the solution for a simply supported case. In the present lecture, week 5 L2, first I will explain that can now with this background, can we understand the recent research articles. So, this is the very recent paper, that is semi-analytical analysis of strength and critical buckling behavior of underwater ring stiffened cylindrical shell. I have just chosen randomly this paper to explain, can we understand whatever I have explained to you. Like in this paper, a cylindrical shell in which there are stiffeners as ring stiffeners are used, and this is used as underwater pressure. So, outside of the tube there is a pressure over there, so it is studied. So, can we understand that these are the recent articles. So, basically the aim of here the basic governing equations. So, initially they have given the heat conduction equation which is in polar cylindrical coordinate, but I have explained you that the section 2.2 fundamental equation of problem. So, here you can see that strains epsilon x, epsilon theta and epsilon x theta. If you remember the shell panel, just in previous lecture I have explained that epsilon x was similar like that, epsilon theta and epsilon x theta. So, because it is a complete shell, so derivative with respect to x is taken care. Now, that using the displacement field, so they have also used that first order shear, that Dolan shell theory which is thick shell theory. So, based on that displacement field they have obtained the strains and divided the strain into two parts. One is the membrane 0 and kx, stretching part and membrane part, and then substituted back to sigma x, sigma theta theta we have obtained in a plane stress case, and then the definition of nx, mx all we have obtained in this paper. So, you are now familiar with these approaches. So, you can understand at least this paper what is the meaning of D1, D2, D3 and so on. And then you see that nx, the constitutive relation for stiffened cylindrical shell A10, A20 basically corresponding to the membrane part, then A11, A21 is corresponding to the bending part. So, same way we have that B11, D11. So, depending upon the any displacement field, some more terms may come up. Same in the n theta, nx theta. So, these terms are coming. And then finally, the matrix of nx and theta is represented like this. And you can see the definition of Aij. So, it is an isotropic shell. So, only E, Young's modulus and mu Poisson ratio is used to find out. So, z times z cube and so on. So, you can see that here the 5 governing equations. So, basically it is a first order shear deformation type theory, and you can see that our governing equations was similar, and these are the dynamic terms mx theta, m theta, derivative q theta. So, whatever I have explained during the lectures, now I feel that anybody who is attending these lectures, now they can understand the research articles. At least very first point to work in any research area, first to understand the existing literature, that what is given and how to understand, means further move with that. So, first we have to understand the existing one, and then later on we can apply our own ideas. So, these 5 equations we have derived like this, same they have derived, and they have now specialized axis symmetric geometry when the theta load are independent of theta. So, derivative theta will go, so it will just reduces to 3 equations, and then they have solved for the buckling case. So, the purpose of explaining is just to expose you that yes, these are the recent research articles in the field of shell, and one can understand that these are expressed like this, and then you seen that the internal work done express Rx, dx, d theta d just same way, because we have developed a very generalized and it is a special case, cylindrical shell case. So, you can now see that with the background of doubly curved shell, even you can understand the cylindrical shell and the paper on the spherical shell, paper on any hyperbolic shell, paper on any conical shell. So, you can understand the at least the state of art based on first order shear deformation theory and higher order, that what are the basic terms are used and how to move ahead to develop the governing equations. And these are the boundary conditions. You can see that boundary conditions in the cyclic and buckling case, and so same way we have nx, because only along the x direction they can specify, along the theta direction shell is closed. But when we talk about a finite shell panel, then we can also have the boundary along the theta direction as well as along the x direction. So, I would like to further go through in this paper. So, just to tell you that the same way we have represented the displacement field either in sin theta or a cos theta, or so, and then finally substituting into that equation. So, A11, A12 are coming as a function of m and n, and then they have solved. So, techniques may be different. So, because it is a free vibration case, there is no transverse loading. So, in that case right hand side is 0. So, eigenvalue problem is solved and frequencies are obtained for the first case. When you talk about a buckling, then compressive load is applied. So, that is solved. So, the techniques of solution is also given in the paper. So, once you have understood the formulation, you can understand the complete paper and you can proceed in your research. So, in this lecture, I have briefly explained that how to understand a paper, that a recent paper. Now, you may be aware, may not be, that can we develop a program. So, what are the basic steps if we want to write a code on cylindrical shell? First, I will explain the basic steps, that transformation of material property, which is very, very important. Whether sometimes we use these material properties modeling in CAE software like Abacus or ANSYS or any numerical software, we need material properties in our hand, or sometimes we do some experimentation, or even we write our own code, that inside that code we include this subroutine that can we get the transformation of material coordinate, material properties. So, that is very much required. So, first I will explain with the help of a MATLAB file. So, I have just copy pasted all MATLAB commands in my PPT slides. So, very first command is CLC. So, it means the very first command, clear the screen. Maybe that some of you may be the master students, or some of you may be the early PhD students, research scholars. So, you may have a background of coding, you may not have the background of coding, but I would like to feel that for the sake of completeness, when I explain the theory, so I will briefly explain that how do we write a code and what are the basic steps. So, in the structural engineering, specifically when we do a continuum mechanics, so clear the screen, you write any code. So, specifically in MATLAB, that in a workspace, if you do not clear, so other variables it may mash up. Then the next is the format. So, generally it is a if you use a format long E, so for this type of structural analysis we should use the long E format. The purpose is that sometimes in the calculation we want the convergence checking, that let us say 10 power minus 9. Then if it is not in long E format, then we cannot work with this type of convergence analysis. 10 power minus 2 minus 3 is fine, but when you talk about more than minus 8, so then it is required. So, depending upon the issues. So, generally whether you write a code for a plate or a shell, any kind of analysis, whether it is a static analysis, free vibration analysis, then we should use the format long E. It is not just a simple calculation, ultimately we have to express sometimes the exponential of something and it comes in very long number. Then the ideal way, we can give input through many ways. We can write, when I give writing a program to our master students at our IIT Guwahati or the research scholars, they generally write in a very hard form, that they give the input just like E and mu and fix and then write a coding of this. So, that is the one way, that in the program you itself you give the material property and you then process it and then finally get that. But that is not the soft form, because every time if you want to do so, every time you have to change in the code itself. Then if you do so, there will be chances that some error may or some other things may be changing. So, we should write a program in such a way that we should have minimum interference but outside information. So, we should not work every time inside the program. We should give the input through a file. That is the ideal way of working in this field, that if we give, can we give input data. Input data means the geometric parameters, means the material properties in the layer wise stacking sequence. So, we should try to give through a input. So, this option is available in all kind of languages, whether you talk about a MATLAB or you talk about a Fortran or you talk about C++. So, whenever you do a programming, so please try to give, if you write a big program, try to give input through a file. The very idea behind that information of your input data is with your hand, you can see for any error. So, basically we have to give the file extension, file name and all these things. So, these are the standard formats that input file extension should be in. So, whatever file name, let us say I want to give a file name of shell A. So, I will give a file name of a shell A dot in. So, its extension will be dot in. The other point is that if we give a dot in or dot dat or dot text, so all these files can be opened in WordPad, so or a Notepad. You can open in MS Word, but in MS Word they will be in very zigzag format. This I have experienced. So, if you open in a Notepad or in a WordPad, then you can work with those files easily. So, the very line by line things are coming. So, these formats are supported by both Notepad and WordPad. .in, .text, .ctl you can open in those So input extension, output extension, and even you can change it also depending upon the situations. Then it is asking that the I file, starcat file and input extension, and then it is making a फाइल नेम दैट कि जो भी आपका फाइल नेम है और उसका इनपुट एक्सटेंशन है. ओ फाइल मीन्स आउटपुट फाइल नंबर 1, पहला आई फाइल मीन्स इनपुट फाइल नंबर 1. सो आई मीन्स इनपुट, सो यू कैन राइट, एंड देन ओ मीन्स आउटपुट फाइल 1 और फाइल 2. सो जिसका एक्सटेंशन है ना आउटपुट एक्सटेंशन 1 है, आउटपुट तो ये एक्सटेंशन के साथ है. देन यू हैव टू इनपुट फाइल को ओपन करना है, दैट वट एवर फाइल यू आर गोइंग टू गिव इट विल ओपन दैट फाइल. तो सबसे पहले इट इज़ द प्रोग्राम विल आस्क दैट गिव द इनपुट फाइल नेम, यू हैव टू गिव द इनपुट फाइल नेम एंड देन इट विल open that file, and then it will also open the blank file of outputs, and then in the input file there may be some numbers that n1 or n2 and it is going to read. So in that MATLAB the command is fscanf is used to read, but if you work in a Fortran it will be read as it is, read, or it may be write if you want to print. So this type of, so I would like to say that at least these first 1 to these lines are very much important. You write any code that you are giving data through input file and you are getting data through output file, and you are providing the extensions properly so that you can open in the basic notepad and wordpad. This is supported for all kind of operating systems. The next step is in that file, that from here it has started, that they have read through the file that how many data is required. In the next file, it is reading a matrix called SAB, reading a matrix, and it fscanf means it is reading that matrix and giving the data A, B and S. The first is assigning that value A, B and S. A is basically, it is written for a, you may say that for a plate, but here arc length of like this, what is the A and what is the B, but for the case of shell you can say that you are interested in terms of a R, you are interested in terms of a span angle, you are interested in terms of a thickness. For a circular, for a cylindrical shell panel, you may be interested in terms of a mean radius R. So you say that very first element of this will be mean radius. Then the next we are interested in the angle psi. So psi may be 60 degree, 120 degree, any you can read through that. And then S is basically in the case of this is maybe H by R or R by H, sorry. So it depending upon, in some of the literature work it is R by H or some more H by R. So and in the case of plate it is basically A by H. So the length upon may thickness of the shell. So most of the time, if you remember in the last lecture I have said that this is the radius to thickness parameter and it is required for non-dimensionalization. So we should do it. Now the material property. So let us say next is a matrix mat1 is read, and in that 9 or whatever n1 components are there, and this is the counting. So first element of that matrix will be E11, second element of that matrix will be E2, third element will be E3 and G23, G13, G1. So basically this is the assignment. So you must know that whenever you are giving data in a input file, you should arrange in such a manner that first value should be E1, second value should be E2, third value should be E3 and G23, G12, G13 and mu12. If you interchange these values, then the program will read something else. So this is very much important, that is why some comments are required in the input file that what should be the first value and so on. Once we read all the 9 data for orthotropic material, then our purpose is to find out the compliance matrix, the component of compliance matrix S11, S22, S33. So when you put a semicolon here, so it will not pop up in the work window, but when you don't put semicolon, so it will come into the outside. So you can see that output window. The reason behind that, whatever you are writing, you must check it. So whether you are getting the S11 rightly or not. Sometimes what happens during writing a program, instead of even E2, you will write again even here just by copying. This may be the error. So when you are checking for this output of that, then you can say that okay, this is wrong. So in this way, whenever you either write a 2 line, 3 line, 10 line, you must check it with another, like with the help of a calculator or with the help of a Excel file or just by. So don't assume that whatever you have written, everything will be okay. Sometimes when there is an error in the program, it looks okay, but once you are going to check it, so you must check it once inside the program, and then output also must check. So there may be error, that because already we have done G23, G13, so sometimes these issues may come up and move on to it. So we have obtained the compliances of the matrix. Then we can arrange in a S matrix. So these are the components. So because in MATLAB you can arrange that in that 0, 0 and all these things, a complete matrix form like this, or you can write a subroutine also that you can arrange that S11. Basically you first say that S is a matrix of 6 cross 6, and then you can assign the elements over there. So that is another way. So writing a code has number of ideas, you can use many ways. So because in MATLAB this is possible, so we did like this. If sometimes this kind of things are not possible, then we have to write like in Fortran in a animal way. Like this, you assign a, you call a matrix 6 by 6 matrix having I 0, zeros matrix of 6 by 6. So there will be 6 by 6 matrix which is having all zeros, and then you can assign now the non-zero elements of that. The next is to find the stiffness, that is inverse of S, and assigning that what is C1, C2, C3 and the components like this. Now we have to find out the transformation that required, because when we go for a fiber angle is different, it is not 0. If it is 90, again we need to transform it. So for at any angle we have to transform this stiffness and compliances matrix. So for that purpose, this is the for loop. So in MATLAB, for loop means for if j is 90, अगर असाइन किया, if j is equal to 0, अगर j की वैल्यू 0 है, then cos theta, cos 0 will be 1, sin 0 will be 0. Else अगर j 90 है, then cos की वैल्यू 0 होगी, sin की वैल्यू 1 होगी. Else आप उसको असाइन कीजिए, a कोई भी वैल्यू होगी पाई बाई 180, and then it will be C1 cos. Basically here I have done for j, so this can be inputted through input file. This is in a hard way that it is for 90, but if I do it 30, 60, so it will go to this loop. So j, for present case I have written 90, but you can give 30, 60, so it is in hard form. So this value we can assign a theta. So theta we can read through input file, theta, so the angle inside the fiber, so that we can put theta is equal to 30 degree. So here theta will be 30 degree and C1 and S1, basically cos and sin is evaluated. Now for the transformation we need at least up to cos square 4 theta and sin times 4 theta. So cos square, sin square, cos cube, sin cube, cos 4, sin 4. So this is the nomenclature C2, S2, C3, S3, C4, S4. So instead of a writing cos, so we have written C1 and S1. So it means the cos theta and S1 means the sin theta. Then the transformed सो बार C11, सो हम कैसे लिखते हैं C11 ऑफ बार, सो वी हैव रिटन BC11. So the transformation, this formula if I write in explicit form is basically cos for C11 plus twice of cos square theta sin square theta C12 plus 2 into C66 plus sin times 4 times C22. So these formulas are given in any theory of plates book or mechanics of composites. So there you can find the transformation formula and you have now written in a code form. Then similarly, so BC2, so basically now you can see that there is some check over there, it should be opposite of that. So this is the error point that, no, this is fine. So instead of a C it will be sin. So and instead of a sin it will be cos. So sin and cos it looks same but the sin and cos is changed now. So BC2. So BC2 का मतलब है C22 of bar. And the other elements are evaluated 1 6 2 6 6 6. So now we have all that C11 bar, C12, C13 and C16 and C26 and C36, 1 2 2 2 2 3 and so on. So a generalized orthotropic material after the transformation is obtained. In MATLAB I know that I want to use the special, so whatever elements are 0 I have put directly 0 here and developed a matrix BC1. So bar C1 is now a matrix in which it is written like this, 6 component and then compiled again. So if it is not in MATLAB you write in C or in Fortran, then you cannot use this kind of function. There you have to write in a, you have to first define a matrix and its size and then its non-zero components. Others you can say that all are 0. And then bar S, BS means bar S, S bar basically inverse of BC1. Now if somebody, some of you may be interested in E bar 11. So instead of that E bar, sometimes we are interested in the engineering constant, transformed engineering constant, then directly you can use from there BS1, BS2 and so on. So and then we can assign ultimately what is this C11, C12 and so on. The reason behind that, in if you write a means want to develop a model in Abacus or ANSYS, there if you write a orthotropic material, so they want a data in the form like this C11, C12, C2214 index. So there you can assign. So from this program you can get all the material property and directly you can feed there 0 degree material property or 90 degree material property or 30 degree material property. Definitely in those software there are options that you first give a value, means 0 degree material property and then they have a that angle transformation and then you can use it. But this is the very simple program, you can use it for directly using the material property. And finally bar C is written here, and this is the output that 6 values in a line will be written here. So I would like to share one output file with you. So you see that stiffness 30, I am sharing the file. So if you are providing the 30 degree angle, then minus 30 degree and 90 degree, so you can get all the stiffness coefficient and it is written in long E format. You can see that this is very much required, and for 90 degree minus 30. So you can directly use these material properties for your experimental purpose, for your further evaluating any property. So this type of small codes are required, and even for developing a code in shell or the solution we have to need, basically we require all these properties. and the input file you can see that stiff.in. So, I am also sharing the input file. So, you can see that it is telling that we have to give first 9 constant and 181 material properties are given, that graphite epoxy composite 181 E1, E2, E3 and so on. So, these properties will be used to transform 30 degree, minus 30 degree, 90 degree, whatever you want to do it. Now, let us come to the how to write a code for our shell case. So, first I will explain that up to the shell constitutive relations. So, I will basically explain the basic terms. So, later on you can make bigger code or more complex and so on. So, these first 10 lines will copy from the previous code as it is, because the file extension, input extension, all these things, and then we can start writing that A, which I have that there. So, now I have written the comment over here. That is very much important. Whenever you write a code, if you do not write a comment, even for yourself after 1 year or 2 year, you will not understand your code. So, the purpose is that you may have 2 copies, like in which one you have a comment, means the comments are there so that you can understand, and if you want to say that for the confidentiality or some other point of view, then you can delete those comments and give to somebody else. But generally we should write until unless it is very confidential that you do not want to give your data or something, then you should not write. But if you are writing a general program, then you should write a comment. It will be helpful for you and for others also, so that anybody can understand that code. So, very first comment, that defining the length and width of the plate. So, instead of a plate, what we will tell, that defining the length and width of a shell. Then A will be a length of the plate, B will be width of the plate. So, यहाँ पे हम लिख सकते हैं, instead of a let us say R, instead of a B let us say theta. So, we can say that mean radius of a shell. Then we can say that span angle of a shell. तो ये कमेंट्स आप लिख सकते हैं. देन थिकनेस, सो R by H, thickness to the length ratio. Then number of layers, yes, we want to give that how many layers are in that shell, 1, 2, 4, 6, 10. Then the most important, that in the previous lecture I have explained that Y0, non-dimensionalization constant. So, Y0 we have to find out non-dimensionalization factor. Then N3 some other parameter for this reading a matrix which is having a 9 component. So, this is written E1, E2, E3 like previous. Now, E1 is not simple, then it is divided by Y0. So, now it just become a number and its order is within, I would like to say that less than 100. So, it may be 20, 30, not more than that, and then it may be 1 or 0.1. So, it will be easy to work with these things instead of working with that 10 power 3 into 10 power 9. So, working with this, if we divide by let us say 10 power 3 into 10 power 9, it becomes a 1, and if it is a 180, so basically it becomes 18. So, we can work with these numbers easily. So, this is the very important concept of non-dimensionalization, but you have to do it very carefully. So, I would like to say that if you do not do others, so at least do the non-dimensionalization of material properties, which is causing main factor, and once you get the results, so what are the factors will come up there. So, you have to multiply with that, then only you are able to match with your results. So, in basically CAE software, Abaqus or ANSYS, you get the final let us say displacement is coming 2.2169 into 10 power minus 9 like that. But in your program displacement may be coming that 5.246, maybe some 10 power minus 3. Then you say that my program is giving this. So, if you do the non-dimensionalization, then you have to multiply or back with that, then only you can match with this. So, D normalization से जिस factor से आपने इसको divide किया था, then corresponding factor you have to multiply it there, then only you will get the final. So sometimes students come up that my results are not matching. I have written a program, so I find out that they have non-dimensionalized like this, but finally the results they are comparing with that. So because these Abacus or ANSYS have written by a very good programmer or smart programmer, they are very generalized one. So we have to, whatever we write our own code, for that we have to convert it to back, or you have to divide by this so that we can match our results. In that subroutines inside that, what is going on inside the code we don't know, but in our program we know that I have divided this, so we have to take care. So through the governing equation you can check it out where how it is moving ahead. So the next step is, let us say the angle between the like fiber angle that fibers are making with respect to theta. So that angle can be number of layers. So for each layer there will be one angle. So this information is read through here. Then the theta is also read through there. Then the loading information, that what type of load is there. Now we say that na minus g z12, so that is minus h by 2 to plus h by 2. So g th1 is defined minus 0.05. Then thickness can be find it out just like S is your R by H. So from here H can be found it out, R by S like this, total thickness. So we may provide the total thickness, or inside that we may provide the thickness of the each layer. So here the thickness of the each layer is calculated. So thickness of the each layer, L K goes from 1 increment 1 to n layer, and calculating the layer wise thickness. So you have given the thickness of the and multiply with the h. So it tells you the layer wise, then the coordinate of that. So आपका minus 0.5 to plus जो भी आपकी उस लेयर की थिकनेस होगी, तो आपको क्या चाहिए, ZK and ZK plus 1, then so on. So it is arranged in a vector form. So thickness of Z coordinates is final is calculated like here. So now it is a ZTH is a vector, row column vector. So in this way we can calculate, and then we have calculated the compliances and so on, then S matrix, C matrix. Sometimes we require formulation in the C, and sometimes we require in the formulation of S. Then we have reduced stiffness. Ultimately we are using the Q11, Q22, all these things. So that you have to find it out, Q11, Q22. I think I have missed that. First we have to define what is Q11 and Q22, that what is Q1, Q2 and Q3, and then the transformation of those matrix Q11 and Q22. Okay. So other things, let us say if you define the Q11, Q22, now you have to find out the matrix Aij, Bij and Dij. So this is the subroutine that it going from 1 to 3, J going from 1 to 3, K layer wise, so it is adding. So basically I have written for this for a plate. So here A1, A1 to A3 and so on. So Aij 1 1, Aij 1 1 is whatever we have, because we have to add it for first layer. Let us say Aij, if I write Aij is nothing but we can write Q, let us say this is 3 layer. So first layer, जो भी आपका फर्स्ट लेयर होगा 1 माइनस 0 प्लस क्यू आई जे 1 1 ले लेते हैं, मानिए आपका 1 1 है. सेकेंड लेयर देन इट विल बी बेसिकली K1 है, इट विल बी 0, then it will be 3, it will be 2 and so on. And third layer. So first if you calculate, then you have to add it. So if you add it, then you write Aij, जो भी जब next time ये loop में आएगा तो जो previous value होगी उसके साथ ये नया factor add करेगा. QMB जो भी layer wise था Z theta minus Z5. Then a factor for this, आपको Z cube चाहिए तो ये Z cube की value कैलकुलेट कराइए, z³ माइनस एंड 1/3 से आप मल्टीप्लाई कर दीजिए। तो जब नेक्स्ट लूप को मूव कराएगा यहाँ के बाद तो ये इसको ऐड करेगा। सो इन दिस वे वी कैन राइट द aij, dij एंड bij. In the next way, if we know aij, bij, then you can define the F matrix, F1, F2. So you can say that F1, F2 like this, A22 minus B22 bar plus D22 bar and R bar square. So you can define these constants. So once layer wise over, now this will be a number, all constants you can define. In the next same way F9, F10, and ultimately after obtaining the value of F1, F2, F3, we have to come to matrix K, where based on that simply supported boundary condition, you have to multiply with this proper sign and define now another matrix K11. So you can write that K matrix define 1 over n, K1 over 2 like that, or you can say that K11, K12 and ultimately make K big matrix, wherever 0 put 0 and form like this, and finally K inverse P will give you the displacement field. So in this way one can do the coding. Definitely that coding requires expertise, but I have just given a brief idea that how we can move ahead with the basic steps, and later on you can write a big code, or there may be after finding there are number of more steps, finding out the displacements at every z coordinate or at every theta value, so one can find it out. So with this I end this lecture. In the next lecture I will explain the finite shell formulation, that finite shell, that how to develop a governing equation for a finite shell and the solution. Because in the infinite shell the solution I have just given in sine and cosine, but for the finite case it becomes a 3-4 cases like axisymmetric case, antisymmetric case, then the journal bending case, number of cases can be explained. So I will explain those things in the coming lectures. Thank you very much.